Welcome back to WAPSI. So we can move to the next section. Okay. So the first question is two particles which are initially at rest. Okay, that means initial velocity of that two particles are 0. Move towards each other under the action of their mutual attraction. If their speed v and 2v at any instant, then the speed of the center of the mass of the system is. So for the rough sketch of this system, if this is the first mass m1 and this is the second mass m2 with their velocity v and 2v, that means the one of the velocity of the particle is v and the other velocity is 2v. Okay, so which one has the greater velocity? Since by explaining we know that the force acting on each object will be the same, because we know that F12 is equal to minus F21, because using that formula we can say that the force is actually on the same on the two object, but the mass is different and the velocity is different. We know that the greater velocity has the lower mass. So this is the mass with the 2v velocity and this is the mass with the v velocity, and they are actually asking that at any instant the speed of the center of mass of the system. See, they are actually asking the center velocity of the center of mass. Okay, center of mass can be neither, it will be staying here. Okay, actually the center of mass will not change, because if the velocity is the velocity of the higher mass, the particle with a higher mass is less and the velocity of the lower mass is greater. But there is another factor, their mass for the lower mass is lower and the mass for the higher mass is higher, so they will cancel each other, and we know that we can say that the velocity of the center of mass will not change. Okay, that means this point will not change. Okay, so the velocity is 0. So moving to the second question. Okay, carefully read the second question. A particle is moving uniformly along a straight line. Okay, it's moving a straight line. During the motion of the particle from A to B, the angular momentum of the particle about O, that means the angular momentum is to be calculated with respect to the origin O. Okay. For options is there increase, decrease, constant, first increase then decrease. Okay. So we need to calculate the angular momentum with respect to this center O. So what is the equation for angular momentum? Vector L is equal to vector R cross vector P is the equation for angular momentum. Okay, and P is constant, P is linear velocity, P is linear momentum, and linear momentum is equal to m into vector V. And they have said that uniformly moving, that means the velocity is constant. Vector V is constant, that means vector P is constant. So L is only depending on R. So how can we define vector R? What is the definition for R? R is nothing but the perpendicular distance between the origin, that means the point at which observer stays, and the line. Okay, the perpendicular distance, that means this will be the R. R is not changing, R is constant, because the origin is not changing, that means the point at which the observer is not changing. If the point the point of the observer is changes to initially at this in here and the final position in here, that means the position is changed, that means the perpendicular distance is changed, then the perpendicular distance will be here, that means it is increasing. The perpendicular distance is increasing, that means the angular momentum will increase. But in here the origin is at here and the observer is fully staying on that position, that means R is not changing, that means the angular momentum is not changing. Okay, That means the option C is constant is the right answer. Okay, in the next year they can be asked like that, the position of the observer is continuously changing with a velocity. That means the r is increasing linearly, therefore L also increase with a constant rate. Okay, so we can move to the next question. A satellite is orbiting close to the earth and has a kinetic energy K. Okay, that means if this is the earth, a satellite is revolving around earth with a kinetic energy, that means it is orbiting. Okay, the minimum extra kinetic energy, if this is a satellite, we are actually giving a kinetic energy required to just overcome the gravitational pull. That means it is escaped of the earth. So we want to calculate the kinetic energy. Okay, and it is orbiting with a energy of K. That means kinetic energy K. So actually in here we must know the equation of velocity, equation for velocity when it is in orbiting stage and when it is escaping. Therefore we need to consider the orbital velocity and we need to consider the escape velocity, and we need to compare these quantities. So what is orbital velocity? Think orbital velocity is nothing but root of gm by r. M is the mass. M is the mass of earth. Okay, it doesn't depend upon the mass of the satellite. So orbiting velocity O is root gm by r. What is escape velocity? Escape velocity is 2 root of 2 gm by r. Okay, so then we want to calculate the kinetic energy. The kinetic energy of orbiting is nothing but half mv square. Kinetic energy is equal to K is equal to half mv square, and V is root gm by r square is nothing but gmm by 2r. Okay, and the kinetic energy of escaping, if the particle is escaping from the orbital, then the kinetic energy at that case, kinetic energy final, and this can be the kinetic energy initial, and the kinetic energy final is half m into square of root of g 2gm by r is nothing but gmm by r. So change in kinetic energy kf minus ki is equal to gmm by r minus gmm by 2r, which is equal to gmm by 2r, which is equal to initial kinetic energy. What is initial kinetic energy? K. We can check with the options. Option A, first one, K. So option 1 is the correct answer. So in here you need to know what is the orbital equation for orbital velocity and what is the equation for escape velocity. Both are depend only on the mass of earth, not depending the mass of satellite. Okay, so then we want to compare that energy. Okay, this is the structure. Okay, you can see in the board, this is the structure of earth and the satelliting which revolving around the earth. Okay, so we need to consider the orbital velocity and escape velocity. Okay, then we want to transform that into kinetic energy and compare the kinetic energy, not the velocities, comparing the kinetic energies. Okay, so we can move to the next problem. A cylindrical container containing water has a small hole at height of h is equal to 8 centimeter. So capital H is 8 centimeter from the bottom and at a depth of 2 centimeter the top surface, from the top surface. Okay, so this will be 2 centimeter and the H, capital H is 8 centimeter. The maximum horizontal distance traveled by the water before hits the ground. So this is the hole, water is coming, the pressure only giving by this amount of water. Okay, this amount of water is the only water which gives pressure to this hole. So water will eject. at the first instant. Okay, the water will be ejected by this hole, and the velocity, the energy will gradually decrease because the mass stored above the hole will decrease by time, and this will get to here by increasing the time. At last it will stop. Okay, so they are asked about this distance x. We need to find that x. So what are the minimum quantities which we need to calculate that value x? To calculate x, we need to know the velocity, ejecting velocity. Okay, this is the ejecting velocity, and time taken to the particle to reach from here to here. Okay, then the displacement is nothing but v into t. Okay, so s by t is velocity, so s is equal to v into t. So if we know the velocity, ejecting velocity, and if we know the time, then s is equal to vt. So how we can find the ejecting velocity? Okay, so we know that the mass stored above the hole will give the energy, sufficient energy to the particle. That means the potential energy stored above the point, above the hole. Okay, mgh. Okay, so the small height is 2 centimeter, so mgh is the potential energy, mgh. So 2 centimeter mgh, height h is 0.02, and what is mass? We don't know. Mgh is equal to the maximum potential energy will transform to the kinetic energy, is equal to half mv square. M and m can be cancelled. Okay, and v square is equal to 2gh, and v is equal to root 2gh. Okay, substituting the values, we get 10 as g, so 20h, h is nothing but 0.02. So 10 into 0.02 is 0.2, and 2 into 0.2 is 0.4. So root of 0.4 is the answer. Okay, I will explain again to you that root of 2 into 10 into 0.2, sorry, 0.02. 0.02 into 10 is 0.2. So root of 2 into 0.2, which is equal to root of 0.4. Okay, put that as like that. Velocity is equal to root of 0.04. Okay, then the next quantity is the displacement. Okay, so actually the height is 8 centimeter. If a particle is dropped from here, it will travel 8 centimeter. That means the displacement is given. S is equal to ut plus half at square. And what is A? A is nothing but the acceleration due to the gravity, and it will travel 8 centimeter. That means 0.08 meter, which is equal to ut. Initial velocity is 0. 0 plus A is 10. 10 into t square by 2. That means 0.16 is equal to 10 t square. T square is equal to 0.16 divided by 10, 0.016. So t is equal to root of 0.016. Okay, so we need to multiply v and t. S is equal to Vt, which is equal to root 0.4 into root of 0.016. Okay, half into A into A into T into, okay, correct. So when we multiply this 4 into root of 4 into 0.016, S is equal to root of 4 into 16, that is nothing but 64. So 0.0064, which is equal to 0.08. Okay, correct, because inside the root there is a 4 significant figures after the decimal. So by taking the root, there should be only 2 significant figures, and the root of 64 is nothing but 8. So 0.08 is the S. That means 8 centimeter. Okay, it will travel 8 centimeter. So which option is the correct answer? Option A, 8 centimeter is the correct answer. Okay. So we can move to the next question. If P, comma Q and R are placed physical quantities having different dimension, okay, they are specifically saying that having different quantities, different dimensions, okay. If P is M, then Q can be L, okay, R can be anything, okay, time T or S, okay. Which of the following combination can never be a meaningful quantity? Can never be, okay. See, P minus Q, can we subtract length from mass? Can we subtract? So option 1 is incorrect. PQ minus R. See, if PQ is the product can be the dimension of R, okay, because we don't know the exact dimension, but PQ can be the dimension of R. So second option is correct. PQ by R. See, the same concept. PQ can be the dimension of R. So PQ by R is also correct. PQ minus Q square. Sorry, PR minus Q square. That means PR can be the dimension of root of Q square. Okay, PR can be the dimension of Q. So it can be divided by R. That means P minus Q square by R. Q square by R can be the dimension of P. Then P can be subtracted from P itself. Okay, so option 4 is also correct. The one and only the one which has some mistake is first option, P minus Q by R. They are already they are saying that they have different dimension. So P minus Q have a different value. So P minus Q is the incorrect option. So never be a meaningful quantity is P minus Q, option A. And moving to the sixth question. Okay, sixth question is one of the nice question. And okay, sixth question. The given graph show the variation of velocity v with the position x. Not that the graph is not a vt graph, the graph is not a at graph, the graph is vx graph. That means velocity is changing with respect to x. Okay, so for a particle of moving along a straight line, okay, which of the following graph show the variation of acceleration a with the position x? So we need to derive a ax graph from a vx graph. Okay, so for doing this problem we want to know mathematics, that means differential calculation. Okay, differential calculus is the basic concept of this. Okay, and equation of a line is are the basic concept of this problem. So from the given graph, vs graph, take the differentiation of this graph. That means the slope of the graph, dv by dx should be a negative quantity because the slope graph is coming to the right as decreasing. That means the graph is decreasing. When x increases, the v decreases, and it is a straight line, so it will be a constant. So it can be stated as minus c1, constant, first constant. dv by dx is equal to minus c1. So dv is equal to minus c1 into x. So v is equal to minus dx. So v is equal to minus c1x plus c2. c2 is the second constant. Put that in a box. Okay, v is equal to minus c1x plus c2. Put that in a box. Then we need to find the ax graph. That means acceleration is to be founded. Okay, so just taking the differentiation of the given equation. So dv by dt, then only we get acceleration. This is equal to minus cx dx by dt plus dc2 by dt. Rate of change of a constant value is 0. So dv by dt is acceleration. A is equal to minus c1 into v. Okay, we get the equation for acceleration. Substitute the first equation in the second equation. A is equal to minus c1 into minus c1x plus c2. which is equal to minus into minus will plus C1 into C1 which is equal to C1 square into x plus Z2. See, the relation between acceleration and x is A is equal to C1 square plus C1 square x, not plus, it will be minus because in the outside it is minus C1, okay, minus C1. So, minus C1 into C2 is just minus C1 C2, okay. A is equal to C1 square x minus C1 C2. That means this is an equation for a line, another line. Compare with y is equal to mx plus c. Okay. What is m? That means m is the slope of the graph and slope is c1 square. C1 square is always a positive quantity. That means the slope is positive. Okay. When acceleration on y axis and x on x axis, the slope will be a positive quantity. The slope is negative, so it must be wrong. Here the slope is 0, so it must be wrong, and the slope is negative, so it must be wrong. Here only the slope is positive quantity. The third option, option C, third option is the only correct option because in that graph the slope is positive. That means when x increases, acceleration is increasing. Okay. So, we can move to the next question. Seventh question. During inelastic collision, the collision is inelastic between two objects, which of the following quantity always remains conserved? Total kinetic energy, total mechanical energy, total linear momentum, speed of each body. We have done already this problem, and from the previous problem in inelastic collision. Okay, in inelastic collision, kinetic energy can be the conserved quantity and mechanical energy will not conserved because in the collision some kind of energy will dissipate by the floor and by the ball if that collision is inelastic. If the collision is elastic, we can say that the conservation is correct. But in inelastic collision, some energy will dissipate by the floor and by the ball due to the collision. Okay, so the conservation of energy can't be the correct. Okay, in the collision, in elastic collision, the linear momentum. Okay, total linear momentum, not the linear momentum by the one particle. Okay, one particle can't be a constant. Okay, total linear momentum is the only correct answer. Okay, so the third one is the conserved quantity. Okay, due to the inelastic collision. If it is in an elastic collision, the kinetic energy, mechanical energy can be conserved. Okay, so carefully read the question whether it is inelastic or elastic. Thank you.